Before talking about Faraday Pail and how do we use it, as well as how it does it work, we need first to know about the concept of polarization. So basically, if you have a neutral object, an object that is neutral, so you have basically the same number of positive and negative charges, so plus, negative, 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 plus, negative, plus, negative, then negative, plus, negative, plus. So this is a neutral object which has the same number of positive and negative charges. So at this point, if we approach a certain charged material, certain object that basically has only negative charges. So what happens here is that we will have a redistribution of these charges. When we approach this object, which is negatively charged, to this object, basically we will have a redistribution of the charges here. The following way, basically. So this is negative, it's going to attract the positive charges. So these ones are going to be positive. Then basically, what's going to happen here, that the positive charges are going to accumulate on this side, and the negative charges are going to accumulate on this side. So this means this is a polarized object, that it has the same number of positive and negative charges. However, this side becomes positively charged and this side becomes negatively charged. And this means this object is polarized in terms of charges. I hope you got the concept of polarization. Now let's go to talk about Faraday Pail. Now we are talking about Faraday Pail, this is basically Faraday Pail, which is consisted of a can of aluminum metal, a cage, a metal cage. Then both of them, they are kind of side on another, they are separated, and they are standing on the top of a plastic cover. And this plastic cover, it's basically, we set it on the top of this metal plate and we call it a ground plate. So you can see it looks like this. So what do we use this one? We use it basically to measure the charges on an object. We put the charged object inside the metal can or the pail itself inside, and using this setup we can measure the charges of this object using the induction method. For example, if this piece was charged and we put it inside, we can read how much charge on this rod using this setup while using the charge sensor. So let's understand first the concept of how this setup makes us to measure the object itself or the charge of the object. So let's draw first the pail itself, the can, the metal can. And let's imagine that we have a negatively charged object that we put it inside. So we have an object here, certain object, and it has a negative charge. And we understand from the polarization point of view, this negative charge is going to induce or attract the positive charge on the pail or the metal pail itself, which means that we are going to have here a positive charge from the inside of the can. And that means that This can, which was neutralized, it was a neutral object. The charges inside are going to polarized. So inside is positive, so the outside is going to be negative. Negative charges. Okay? So if this one was, for example, like a negative Q, this one a positive Q, and this one is a negative Q. And if we basically put a sensor, charge sensor here, and this charge sensor we connected, it has two wires, one to the ground and one to the pail itself. We can measure the charge negative Q, which is exactly the charge of the object without affecting the object. This is the main idea. We do not need to disturb the charge on the object itself, but we need to measure it. So we use the idea of induction, that we induce the charges on this object on the pail, then we use a charge sensor in order to measure it. Okay? So the idea of having the cage around here, which this cage basically it stands on the top of the floor, the metal floor, and we call it the ground floor. And this ground floor, we will know later inside the setup while doing the experiment that we are connecting this cage with the metal floor using the alligator cable. So that basically from here, when the outside of the can or the pail itself is a negative charge, we create here a positive Q on this one. So we keep the can kind of polarized. Okay, I hope you got the idea of Faraday Pail and what is the reason that we are using it and how does it work, basically based on the polarization and the induction idea. So let's start first with doing the setup itself. So we will bring the Faraday pail as we said here. Then we will connect the cage, this cage, with the ground plane. Then using the hand strap, we will connect the ground plane on our wrist. So let's have it here. Okay, so it's on my hand. Then let's connect the sensor itself. So we have the sensor here. So we'll connect this side to channel 1, for example. Then we see here, let's start to get the values in nanocolumns, a charge. And let's connect the charge sensor to the pail, the Faraday pail. We will connect this one to the ground, then this one from inside here. Let's actually connect it here. Okay, so this one went here. Then Okay. So you have it here, minus 13 nano charge. So let's reset using this button. We press it. You can see it becomes almost a 0.3 nano coulombs. Let's right now see what happens if we rub or do friction between some of the materials, different materials. So we'll get the dump cloth, we'll put it here, and we have this rod, which is basically a nylon rod, and we have here the vinyl. So let's see first how much it charge on this rod. So we put it inside the pail, as we see. So we can see that there is no change in the charge. If you see here, 1.7. If we put this one here, there is no increase. It's almost the same. So it seems there is no charge here. So let's rub and see what's going to happen. So when we rub the vinyl with the nylon, what happens basically, the nylon becomes positive. So let's see. Did it become positive? Oh, it becomes 3.94. Let's rub it more. Maybe it's not enough. We need to have a higher. Okay. Oh, wow. It becomes 15. As you can see here. Almost 10 nanocoulombs, 11. So while rubbing the nylon with the vinyl, the nylon attracts positive charges and it becomes positively charged. And we can see if we put it on the damp cloth, just touching, do not rub it or do friction, just touching. Let's see charges on it. So the charge is gone. We dumped the charges here. So let's see if we rub the PVC with the wool material, what happens? So we have here with the PVC. Let's see, let's reset this one, the charge again. Then let's, just in case, dump all the charges. We put it here. We see that there is no change in the charge. So when we rub the PVC with the wool itself, this one becomes negative. The PVC becomes negative. So let's see. Rubbing. Then let's put it inside. Oh, becomes -3. Let's rub it more. We needed a higher value. So it's minus less actually. Let's see what's happening. Oh, -8 or -7. You see? So rubbing the wool with the PVC, this one attracts negative charges. So right now we have the charge separators. Let's see also what happens if we rub them together. The gray one is PVC, the white one is nylon. You can see. So basically let's dump it here on the cloth. See how much charge does it have? Nothing. For this one, the nylon one, put it here, almost nothing, also has side. So let's rub them together like this. and the nylon is going to attract, wow, 7 becomes 9 nano coulombs almost. So it's positive, and the PVC, it's -5, so it becomes negative. That sounds good. So let's dump them to remove the charges. So this is just generally watching what happens when you are kind of rubbing different materials. So let's start with the lab itself.